Okay, so what we can then, let's try to understand what the problem is asking. Okay, the very first, as we have given, is what we have given nums, right? And this nums is nothing but an array, right? So for every index, let's call I, let's start from index 0. Can we say that? So for every index, right, that start from 0 to n minus 1. So in this array, you must find the smallest subarray that start from I, such that you can say the bitwise OR of the subarray is as large as possible, right? Let's understand how I'm trying to tell you how the question is asking. Question is saying 1, 0, 2, 1, and 3. So each index start from where? We know that array start from 0, 1, 2, 3, and 4. How many elements we have? 5. So index start at where? At 0 and set 4, right? So this is 0 and this is your n minus 1. This is the question saying. Now understand. It is saying for every index, this is your I, right? That start from 0 to 1, 2, 3, 4. Can we say that? So for every index I in this array, right? What we need to find? The smallest array starting at index what? At I. So you have to find the smallest array. Let's suppose we start from here, I. When I is 0, right? What is the smallest subarray that start from I? Is let's suppose we'll call 1 itself. There can be many subarray, 1, 0. There can be 1, 0, 2, right? Like this. And there can be many subarrays will be there, right? Where? At index I am talking about. But it is saying you must have to find the smallest subarray starting from any of the index I, for each I you can say, right, such that the bitwise or of that subarray, let's suppose any of this subarray is as large as possible. Can we say that? Right? Means we want to consider a subarray that start at I to the end. Let's suppose call for the end, right? Any subarray that start at some index I and to the end. But this array, this subarray is can be as smallest as possible, because question demands this smallest subarray with maximum bitwise OR. And that is why it is saying if you're taking the bitwise OR of that subarray is as large as possible. I hope you understand the problem. So can we say that in very simple term, for index I, what's the shortest subarray that gives the biggest OR, right? Can we say that? We can say that, right? This is the problem is saying. I hope you're trying to understand, right? I hope you are trying to relate what the statement is saying and what I'm saying, right? First of all, find the smallest subarray, and then for that subarray should have as large as possible, means maximum bitwise OR of that subarray. Means it's very simple, means find the smallest subarray with the maximum bitwise OR, right? So can I say that, give me 1 second. So can I say that, let's understand about this output first. Okay, let me clean it. Okay, so what's this input and output represents? This input is an array, right? And this output is also an array. This is your nums and this is your answer as per the question is saying. See, it's an array answer having same size, right, of n, because n is the length of the subarray, is the original array, and the original answer will keep answer at I. Answer at I is an element, is a also an element of the answer, you can say, but that is we have to define the length of the minimum size subarray. What was the smallest subarray? And that should have the size, right? There will be some size, because that should not be non-empty. It should be non-empty subarray. Understanding? Means we want to find the subarray, but it should be non-empty. There should be at least one element. Okay, one that we have seen here. Okay, that length you have to store at each index. Okay, it means at index, let's suppose call at 0, right? At index 0, the smallest subarray starting at 0 that gives max or, and its length is what? 3. What I'm saying, what is this means? This means at index 0, right, of the array, that is what? At 1. Let me write again. 1, 0, 2, 1 and 3. What is the index? At index 0. At index 0, the smallest subarray that start at where? At 1. At 0 means this 1, right? It gives the max or, what? Maximum bitwise or, we can say max or, right? Is of length is what? Is 3, and that is giving a 3. So this is the question is saying. You have to understand the question and output, right? And then you can perform the writing the code. So at index 1 here, we are also getting 3 here. Means at index 1, right, the smallest subarray starting at index 1 for max or is having length 3, and so on. I hope you understand, right? Now understand, give me 1 second to clean it. Okay, now understand the concept. I already explained yesterday, but I am thinking if any one of you is new, you should not go to the previous video to watch the bitwise or. So I hope you understood study this bitwise or. If not, don't worry. This is an operator, right? In bitwise or, either you are doing what C or digital electronics, right? Or computer C, right? You have seen that this bitwise or, right? Where what bitwise or is doing? Just think. Bitwise or combines bits, right? What are the bits? What are the bits are there? 1, 0. What will come? Study we have seen, right? 1, 0. Either there is 1 and 0. Any of the switch is on. We'll say it will be on. Like that we used to remember, right? If both switch are on, if both are 1, remember what will come? 1. Understand? If both are 0, both switch are off, it means it will be off. If there is one more case, okay, this flip, you can use this flip, 0 and 1, it will give you what? 1. So these are the 4 flip have, which it will be only switch off in the case of both switches off, right? If both switch are off, only it will be off. So this concept is called bitwise or you can say or. So or accumulates on bits, right? It accumulates on bits and never turn off as 1, right? It never turn off, only in the case of both. So the or result always grow, right? The chances are here is what? 3 times it's getting what? Positive value here, 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 and so this or results always grow or stay the same as we include more elements. right? I hope you understand, right? Let's try to understand through the example that we have given here. Okay, let me clean it. So can I take the, okay, let's try to understand. Okay, very first what we have given is 1, 0, 2, 1 and 3. This is the example we have given, correct? So we'll go through the index 0, 1, 2, 3 and 4. These are what? Index, and these are elements of nums. Can we say that? So we'll go from index 0 to index 4 and we'll try to find the smallest array, subarray, right? That gives you the maximum or from that position. Let's call from position 0. So when I is at 0, let me change the color. Let's take it this one. When I is at what? At 0, right? So it start at where? At 0. What is the subarray? What are the subarrays will be there? Just think. Subarray will be what? Very first is 1, right? If we'll take OR of this, what we will get? We will get 1. Next, we'll take, next is what? 1 and 0. The very first is from here. We'll take only one this. Then these two will take. So we'll keep growing, right? Till here, then here, then here, then here, and then here. We'll keep going that. So let's try to do that. Operate the OR here on 0 and 1. We know that when we'll do what? 1 and 0. What we will get? 1 we will get. So we'll say 1. Next what we have? 1, 0 and 2. Okay. Apply this. Let's call very first. We will apply what? 1, 0. What we will get? 1. And then we have to operate 2. On this, if we'll update, what we will get? We'll get 3. We have seen this one, right? Yesterday. So we'll get what? 3 here. If we'll apply the OR, so we'll get 3. Here we'll get 1. Here we'll get what? 1. Right? Next we'll apply 1, 0, 2, 1. Apply the OR. Once you will apply this, what we will get? Very first was 3, right? 3, and we'll apply what? 1. What we will get here? We'll get 3, right? So we'll get 3, right? Next is what? 1, 0, 2, 1 and 3, means all the elements, right? So here till the here what we have got? We have got 3, 3 and 3. What we will get here? 3. So we'll say we'll get here after applying what is 3. What maximum we got? Maximum bit or is what? Is 3, and that is why we are getting what? 3. So if we'll take the maximum of all these, right? What is the maximum? Is 3. We are getting here, here and here, right? So we are getting 3, right? So we'll store at here output as a 3. For index means answer at 0. For this 0 is what? Is 3. That is why it is coming. Similarly, we have to find the maximum or we can get from all the indexes. Okay. Now, if you go with the 1, you have to apply with what? 0, then 0, 2, then 0, 2, 1 and so on, right? Like that you will find all of them and you will see you are getting 3, 3, 2, 2, 1, right? Now the tricky case is, what is the tricky case here and what is the hidden insight, you can say, or what is the hidden logic is here. The very first, try to understand with the naive approach. Okay, then you will understand. If we'll try every I and we'll check all the subarray that start at where? At 0 to, we have seen at 0 to n minus 1. We'll try that, right? And we will calculate what? OR. As you have seen, we have tried to calculate the OR. So this will work and it will take what? O of n square, because we are trying to find all the subarray, right? You can see here we are trying to find all these subarray. Are we trying or not? We are trying to find all the what do you call subarray. So we'll check all the subarrays from 0 to n minus 1, and if we'll calculate the OR, right, it will take O of n square, and it will be very slow, right? Very slow, very slow. Okay, means maybe it will take what, lack of n square. Maybe it is taking millions of trying to find it, right? It will find if the number of uh, elements in the array will increase. I hope you understand. This is very simple. So how we are going to optimize? What is the optimize idea that we can apply here? So instead of recalculating OR again, right? If you understand, to calculate this from here to here, we already knows that I have directly put here, and then I have applied these three, right? We have applied 3, then these 3, we have applied this. Means this was a pre-calculated that we knows that we have calculated here in the previous one. Means instead of recalculating the ORs from the scratch for every I, right? Means very first we have already counted here, then we have applied here, right? Then we have got here this one, right? Let's suppose we already applied these 2, right? We got 3. So when we are calculating this one, so we already know this part of result, right? So we will directly apply this. Similarly this one, means we are trying to recalculate, right, for every I, and we can work from the right to left, right, like that. Better what we can do, instead of recalculating from the scratch for every I, we can walk what from right to left, and we say that, and we'll keep track of the last seen index. What are the last seen index we have calculated, right? So for bit 0 to 31, right, we know that for each bit from 0 to 31, can we say that this will help us to know how far we must go to capture all the ones, right? That might contribute to the max OR. Possibility is that, right? And so we will use, let's suppose we'll create a has, or you can take array, right? We'll take a last scene. For now, you can take any of these. Either you take array or you can take a has map, and at each index is nothing but a bit. At that index, we'll call index, and we'll record the last spot that we have calculated. What was the scene, right? And so it is good, right? Because we are going to use that. Okay, so our approach is, we'll start from where, from left to right to left, right? And we'll keep track of every bits that ends. Okay, means if you think that about the complexity, it will take what, let's suppose n is the number of elements, means just multiply by 32, means this will become what, O of n, O of n into 32, and that will be your efficient what you call time complexity rather than of n square. Okay, so what is our intuition? Let me clean it. What is our intuition? Our intuition, like for every index, right, every index, we have to find the smallest subarray that start at where, at index I, that produce the maximum what, bitwise OR, right? Means from I to the end, correct? Means a start and the end. Understand? Means we have to find the smallest subarray starting at index here at I, that is a starting index. It will reach to the end. Those all the subarrays we have to find, and we have to find what, the maximum bitwise OR for the all the subarrays, right, that we can find from I. Means we find the OR from index I to j. Can we say that? Means the possibility is that if you have nums, this will become what, nums at I, or nums at I plus 1. Can we say that? Or nums at I plus 2, and so on, right? Till what? Nums at what? J. Can we say that? So this is the what? We can say definitions. We find the or from index I to j, means every what you call elements that is from I to j, you take the or, you take the what? Or, keep doing the or, and you find the smallest j. What you need to find? The smallest j, such that this or become what? Maximum, right? Or from I to j. So can we say we'll take result is what? J minus I plus 1, because we want to find what? The smallest j, the smallest j, such that this or becomes the maximum possible from I to j. So we can say result will be j minus I plus 1. We'll understand this, don't worry, we'll understand this, okay? Let's try to understand with the example that we have already seen, right? Give me 1 second, guys. Okay, so very first, let's suppose we have a subarray, right? We have what? Subarrays. Can we say that? What are the subarrays there? We have 1, 1, 0. We can take, I'm talking about when I is 0, right? 1, 0. Then what we can having, you can see from here, okay? Then we can have 1, 2, sorry, 0, 2, right? This will be the possibility. Then there basically 1, 0, 2, and 1. And the very last is 1, 0, 2, 1, and the last is 3. Okay, so these are the sub arrays, we can say, we can get from where? At index I, from these nums. Can we see that? If we'll try to find what? Respective or calculations, what we will get here, right? So from, if you take the or of this 1, we'll get 1. Very simple. That 1, 0, we will get what? 1 again, because we know 1 and 0 is 1. We will get the 1, right? So we'll get 1, 1, 0, 2, right? Let's suppose from here to here we are getting what 1, okay? And then we are getting what is 2. Here is 2. So we can take like this. Let's suppose 1 and this is 2. Okay, I'll take it as a 2, or let's go take 1. You have to put the value and you have to understand. Okay, for 1 you have to take what? You remember 8, 4, 2, 1. We can calculate, we can find it. So this is 0 and all, this is 1, and all become 0, 0, 0. Give me 1 second to clean it. Okay, so if you remember what we used to do, 8, 4, 2, 1, we'll take 0, 0, 0 and 1, right? And for 2 it will be 1 and rest of the thing is 0, 0. How we are calculating this? This will become 1 and this will become what? 1, and rest of the thing is 0, 0. So this is coming 3. We can take 3. Okay, for this I'm talking about for this one. Okay, next we have 1, 0, 2, 1. So we know that from here to here we got 3, and we'll take 1. So 3 and 1 become what? Is also 3. From here to here we are getting 3, and from here is 3. So 3 and 1, 3 and 3 is getting what? 3. So can I say that when we are calculating the subarray, right, we are getting what? We are getting or result. So we can say or result. We'll take a or result that we have to find. Okay, so or answer we can say. So can I put what? Not answer, result we can take. That will get confused with this answer. So what will become? Let's suppose 1, 1. Let's suppose this will become what? What is the result or result? Let's call it 0, 0. Then we can say what? 1 and the 3. So max or we can find how the smallest value that we will get from the smallest array that we will get from what is 3. We can say from the 3. So so don't be get confused. Okay, so this is your or result in the binary. Okay, so what I'm trying to get here, let me clean it first. Let's understand how we are calculating the max or. Okay, so very first, what we want the smallest array that start at I, right? Means what is happening, or will take, right, or of nums will take from I to j. Can we say that? I to j, right? And it will give you what? It will give you what? It should be the max or between nums, you can say I to the n minus 1. Can we say that? So let's call it index. If this is index, we'll take at index 0. What are the sub array? Sub array that starting here. Starting here at where? 1, 0, 0, 1, and 3. Just for understanding. If we'll take this one, what is the OR result? Right? The OR result OR in the binary. What we will get? Means we'll take 1, then 0, then again 0, again 1, then again 3. Just for understanding, what we will get here? We'll get a 3. Okay, you calculate it, you will get 3. Okay, and the decimal, if we'll take decimal, it will give you 3. Similarly, if we'll take at 1, right, for here, let's suppose we'll get 0, 0, 1, and 3, right? We are taking from at 1, so I have taken all the elements of the array, and we are getting now we are at index 1. So index 0 it was, so we have taken full. Then at index 1 we're getting what? 0, 0, 1, 3. We are discarding the 1 here. Okay, what we will get here? Similarly, we will get what? 0, 0, 1, and 3. We will get what at here? 3. Similar to here, means the decimal value is 3. Again, you will keep going there. Let's suppose for 0, 1, 3, we'll get here 3. 1, 3 is 3, right? Here we will get 3. In the last, we will get a is at 2, then 3, then you get 1, 3, right? What we will get here? 1, 3, we'll get 3, then we will get 3. At the last, index 4, we'll get only 3. Here we will get 3, and they will get 3. So if you see, we are getting all maximum is what? All are 3. Okay, means all maximum odds are 3, and so we'll, in this case, we'll return answer is 3. So similarly, you have to find at all the indexes, right? So can we say that, like what we have observed here? Think, means if there is an array, right? If there is an array, let's write here. Okay, the array is what we have chosen: 1, 0, 0, 1, 3. This is the array we have chosen. Can we say that start at where? At index 0, 1, 2, 3, and 4. Okay, and what are the values we have got here in the here? So we'll say 3, 3, 3, 3, 3. All are 3, 3, 3. So this is your max OR, and you have this result. You will return this result. I hope you understand. So like that, we will calculate it. Okay, so this is our approach that we are going to see it. Let's understand the code. So very first, what we should do, we should define these things, right? Let's suppose we'll all the size of the array will get from what? Nums at nums dot length, right? We'll get, and then we have answer. Let me zoom a little bit. Okay, so you will get the answer, right? You have to define the answer. This will be the result that we will return it, right? Very first, we will define the last scene, right? So the last scene is what? We are writing a array that will store the last scene index for each bit that is start from 0 to 31. Means this is the last scene index for each bit, 0 to 31 bit, right? 32 bit we have, right? So for each bit we will store its index. Okay, and we'll mark a loop, right? We'll create a loop, and we'll initialize all the bits with -1. Means this has not been seen yet. Okay, and then what we will do, we'll start from the loop. As we told, means right to left, right? We'll go to right to left and we'll check for all the bits. We know the bits is start from 0 to 32. So let's say we have a very small array, that is nums. Let's suppose call 1, 2 and 3. Okay, very small array we have, right? So if we'll take the binary of 1, we'll get what? Binary of 1 is what? 1 will get what? 0, 0, 1. For 2, we will get what? 0, 1 bit all will take, then we'll understand. Okay, 8421. Remember 8421. Then we'll take what? 1, 0. Yes. 3 will get what? 1, 1. And this is 0, 0. Can we say that? So these three are the binary of these elements of the nums. Okay. So for each I in reverse order, we'll check which bits are set in nums1, nums at I. Means we want to check which bits are set in nums at I. Okay. Means we will initialize the last scene. We have the last scene at 32. Let's suppose bit at 32. Let's suppose all are what? -1 initially. We have initialized that at -1, right? Meaning no bits seen yet, right? No bits are seen yet. Can we say that? So for each position, each bit position from 0 to 30, 32, 31, we can say, right? We'll shift. What we are doing? We will shift right by a bit position, right? So we want to isolate the bit at that position, and that we are doing what? With the and 1, right? And we'll check if it is 1 or 0, right? If it is 1 or 0, there is two conditions. If it is 1, means we have to update the last bit at what? At I, right? What we are doing here? Very first, we want to iterate over the bits 0 to 31. For each bit position from 0 to 31, initially it was last all seen was what? -1. So no bits are seen yet, we can say. Okay, but when nums at I making a shift, that is called bit, right? If for each bit position that is start from 0 to 31 will make a shift nums at I will take a shift right by, this is right by a bit position, right? Only one bit at a time we will go, right? One bit each time will go. Okay, so it will give you what? It will give you some value, means it will isolate the bit with that position, and we'll check with and check if it is 1 or 0. If it is 1, if this gives you 1, right, or 1, that is why we will check. If it is 1, means if we need to update that index. So let's understand how. Okay, so very first let's go with I equal to 2, means we are talking about nums at 2, which is what? Is this 0, 0, 1, 1, right? Sorry, at here 0, 0, 1, 1, right? So this is nothing but what? I'm not talking about this. This is last from, we have to start from the last, right? This is 3. Okay. So when I is 2, nums at 2, what we will get? 3. And that is value we have got is 0, 0, 1, 1, this bit. So if we'll take at bit 0 will apply this one, because we have go to 0 to what? 32. But we will not go to till the 32 because we have only some bits are left, right? So let's call bit at bit 0. We will take what? Nums at I what? Is 3. We have seen, right? 3. So 3 will take a right shift and will pass the bit is at what? At 0 initially. So 0. Can we say that like this? And we'll take 1. Okay. And we'll apply 1. Is it coming 1? Right? It will come 1. And so we'll say last seen at 0 is 2. You apply 3, you will take the shift, you will get what? 1. What you will get? At 1, right? So last seen at 0 will update the I, because I is currently what? Will take 2. We are taking 2. Will update last seen at 0, will update this, because we are getting what? Is 1. Those who are beginner, give me 1 second, guys, or we should go with everyone. Okay, so let's understand how this works. 0, and what we have after this, we have and 1, right? And we are getting what? We are getting this value as a 1. Can we say that? Very first, understand this. 3 means what? We are talking about 0, 0, 1, 1, 3. Then we have to take what? This value. So 3, 3, we are taking the right shift with 0. So this will perform a right shift on the number 3 by position 0. We are shifting a number by 0 position that results in the original number, means will give you itself is 3. So if therefore we'll say 3, we are taking the right shift, it will gives you what? It gives you 3 itself. Understand? Now we will apply the bitwise operation. We will apply. It's called a bitwise, not or, it's and, bitwise and. So this expression 3 and 1, it performs a bitwise and operation between 3 and 1. This is nothing but your, this part is nothing but 3, and this part is nothing but 1. So between 3 and 1, right? So binary operation 3, we have what? Is this one, and for 1 we have this one. Can we perform both of these? Let's perform 0, 0, 0 and 1. If we apply this AND operation, 1, 1 is what? Is always 1. Any of the switch is 0, right? Means off, will mark it as off. And so we are getting what? We are getting 1. If this matches, we will update the index. And so we will update this index. Understand? I think it's clear, right? So like that, we'll keep checking the value and we'll update it. Understand? All the indexes. Similarly, when we'll talk about when bit increases to 1, right? What will happen? We'll say 3, we'll take a shift at 1 and we'll mark as what? 1. It will give you 1, right? So we'll update the last scene at 1 is also 2, right? Again, what we will do, for the bits will take 0, and bits at 0, this is 2, let's suppose this time. So we'll go to 2, 230, bits 2 to 31. We'll see all will give you 0, and will update not required. Only we are getting for index 0 and 1, and both we need to update, right? Index 0 scene is I is what? At 2 we have taken, right? For the index, and for 1, when bits is 1, will update again is 2, means both index will update its I value. I is what? At 2. It means those last scene at 0 is equal to 2, and last scene at 1, right? What we will get is also 2, and rest of the thing will be what? Till the n-1 will be -1 itself. Nothing will be there. Okay, means no needs required. Understand? So we'll keep doing that until the I is to, let's suppose it was 2, then 1, then 0. This is your I, right? When it was 2, we have updated these 2, right? When it will go to 1, because it will give you, let's suppose 1, we can update last 2, right? Let's suppose when last is sorry, nums at this is nums, right? nums at this is what we got 2. It was 1, 2 and 3. So this was what 2, 1 and 0. So when it is 2, we'll check what the value, right? So let's call 2 and we'll make a shift 1, we'll get 1, right? If this will give you is 1, it will give you 1, right? It will take the shift this and this one, it will give you 1. Okay, so we will update the last scene again. From this it was 2, now we will update at 1 is nothing but 1. Index is now is at what, we are at index 1, so we'll update it 1. So and others not required, so will not do anything. You have to keep doing that. Similarly, you will, when you will go again at index what, at 0, right, you will get 1. So we'll update this index as 1. Previously it was 2, now it will update both indexes 1 1. Understand? Like that you will go and will keep updating the last scene position. Every time you have to update for all the bits, for all the numbers. Okay, now understand this part. So we have to find the farthest indexed we need to go to include all the bits, and for that you will go all the bits, you will check if last scene is not 1, you will get the max value. What is the max value is coming, you will get the max value, right? So max value, as we know that I told you, right, j minus I plus 1. So this is your as a type of j, so we'll get your j, you will return it in the answer. I will keep updating your answer and you return the answer. I hope you like this video. Let me know in the comment section that you like or not. Okay, anyways, thank you for watching this video. I'll see you in the next one. Please like, subscribe this channel, so I can provide you the better videos, better content, and please keep supporting ExpertFunda. Most of